Hello, everybody. We're going to take a look now at Chapter 9, focusing on business and the costs of production. So, in a business, we have all sorts of costs, ranging from economic costs, short run production relationships, short run production costs, long run production costs, and finally, some applications of them. So, what is an economic cost? And an economic cost is any payment a firm must make to obtain or retain the services of a resource. So you pay your accountant, that's an economic cost. You buy new vehicles, that's an economic cost. You rent a new building. Those are all forms of economic costs, and they're necessary to run a business. Explicit costs are any time payments are made for supplies. So you're paying people that don't own your business money for some sort of a supply. Those are all explicit costs. Implicit costs are the monetary payments the self-employed resources could have earned in their best alternative employment. So if you make a business, not only do you have explicit costs, obviously it's expensive to start a business, you have implicit ones as well. Basically, what kind of money could you make had you decided not to work for yourself and get a job at a corporation or doing something else? Those are implicit costs. And they're opportunity costs. They're the opportunity costs of using cell phone resources or your own time and ability. And that's the difference between them. If we take a look here, we have two forms of profits. Accounting profit is revenue, or what you make, minus your explicit costs, or what you spend. So in an accounting sense, that means we made money. Whereas economic profit is accounting profit minus implicit costs. And what that means is not only did you make an accounting profit, you still made more money than you would have doing something else. So revenue minus economic costs, that is economic profit. So what's the difference here? Well, the difference is, remember, accounting profit just takes into account your explicit costs or what you spend money on to run your business, whereas an economic profit takes into account the money that you would have made elsewhere. So you want to make sure that you are making a profit in both senses. It's entirely possible to make an accounting profit, but not an economic one. So in the short run, so the short run is the period of time, the immediate period of time. You can't really change much in your short run. You can't really alter your plant capacity, think of contracts and existing supplies and all of that, but you can change output to a degree by increasing or decreasing your variable inputs. In a long enough amount of time, everything is variable. You can change anything. So one of the primary characteristics of the long run is it's enough time for people to enter or exit the industry. If you're making a product no one wants anymore, in a long enough period of time, you'll exit the industry. If you see a new trend catching on, some new tech device, and you have the ability to manufacture it, you might enter the industry. And it differs among industries. Every industry has a different amount of time between what we would consider the short and the long run. A company manufacturing t-shirts could adjust quickly, but a company drilling for oil is going to take a lot longer to vary their capacity. So what are some of the relationships in the short run? Total product is the total quantity being made. Marginal product is the amount we will change our production when we vary our labor by 1 unit. So if we hire an additional worker or buy an additional machine, whatever we do for our labor resource, our marginal product is how much it's going to change. And average product is simply your total product divided by your units of labor. Units of labor can be people, it can be machines, whatever you're using to actually do the work. So what is the law of diminishing returns? This is something you may have encountered before. And it states that resources are of equal quality. Technology is fixed, variable resources are added to your fixed ones, and at some point marginal product will fall. So what do we mean by this? You can't just keep increasing the amount of something you'll make into infinity. So if you have a fixed plan, a factory, it'll become overcrowded eventually. You'll run out of room to buy more inputs or hire more employees. And then you'll have to build a new factory, which costs a tremendous amount of money. And it's going to make it more and more and more difficult to keep increasing production. Your costs will keep going up. And as a consequence, marginal product will go down as you keep increasing. And we'll take a look at an example on the next slide. So if we look at this slide right here, so as you see here, total products rising at an increasing rate, but eventually it levels off and even starts to fall. And this is our law of diminishing returns. And the reason this happens is because, remember, it becomes harder and harder to keep increasing. So if a firm has hired so many workers, it now has overcrowded factories and it's impeding the workers' ability to produce. Total product will start to fall and marginal product will become negative. So as a consequence, you'll eventually hit a point where you can't just keep increasing the amount of something you are making, and that is your law of diminishing returns. Let's take a look here. So fixed costs are costs that don't vary with output. The rent you spend on your factory, for instance, is a fixed cost. Regardless of how much you make in your factory, you're going to still have to pay that amount in rent. So that's considered a fixed cost. Variable costs are costs that do. If you make more and now you have to pay people overtime, that's a variable cost. So variable costs, payments for materials, fuel, power, transportation services, labor. You use more power if you're making more of something. Those cause your cost to go up. Or fixed costs, the rent on your factory, your business insurance, any of that, those are fixed costs. And your total costs, if you ever see a question on that, is pretty straightforward. It's just the sum total of all of your fixed and all of your variable costs. And this is an example of a schedule here showing the more we make of a product. As you can see, our fixed cost doesn't change, but our variable cost does. So our average fixed cost is going to go down the more we make of something by rule because it's fixed. We're never going to have to pay more. So the more we make of something is good. We can offset our fixed costs. But our variable costs are going to go up the more we make of something. And you can see the average comes down up until a certain point. But once we hit a total of 8 units, it starts going back up again. So your variable cost average can actually go back up the more you make of something. That's that law of diminishing returns, and also the fact that the more you make of something, the more it becomes more and more difficult and expensive, all of that to do. And we also have our average total cost as well, which is just simply total cost divided by quantity. You can see the different numbers, and the marginal cost, the change in cost the more we make of something. So total fixed cost is independent of the level of output, and total cost is the sum of fixed cost and variable. Total variable cost does change with output. So the only thing that differentiates total cost and total variable cost are your constant fixed costs. Total cost and total variable cost look very similar. They're parallel. The only difference is the amount between them is your fixed costs. The space between total cost and total variable cost is your fixed cost. That red line there, because it's fixed, it's not going to change no matter how much of something you make. And average fixed cost is total fixed cost over quantity. Average variable cost is total variable cost over quantity. Average total cost is total cost over quantity. And marginal cost is the change in total cost over the change in quantity. And here's some average cost curves right here. So if we take a look, average fixed cost is going to keep going down the more we make of something by rule. Average variable cost is going to drop and then start going back up the more we make of something, and the same thing with average total cost. It's going to drop a lot. Eventually we'll hit a point where we're making so much the average total cost is actually going to start ticking back up again. And your average fixed cost is just simply the difference between the average total cost, and the average variable cost. And that's something to remember. The white space between the average total cost and the average variable cost, that's your average fixed cost. And marginal cost is our change. And as you can see, it's going to become cheaper and cheaper to make something and then start ticking back up again. So the more we make of something, costs are going down. Eventually we hit a certain quantity, and now the more we make, the costs are going back up again. So marginal cost and marginal product, what's the relationship between them? Your marginal cost curve and your average variable cost curve are mirror images of the marginal product and average product curves. They're literal mirror images. Assuming labor is your only variable input and its price is constant, when your marginal product is rising, your marginal cost is falling, and when your marginal product is falling, your marginal cost is rising. And under the same assumptions, when average product is rising, average variable cost is falling, and when average product is falling, average variable cost is rising. So if we look here, marginal product is going to go up, we'll hit a certain point and it's going to go back down again. Same thing with average, and it's just the marginal cost and the average variable cost curves basically flipped over. They're mirror images of each other. And if we look here, this is relative manufacturing costs for selective nations as a percentage share of exports. So in the USA, we consider our cost 100 and we're comparing. So anything larger than 100, it costs more to make something than we do. And anything less is cheaper. So China is less than us. China's a manufacturing powerhouse, but they're not the cheapest country to make things in, although they make the majority of the world's products. But if we look here, once again, any bar larger than 100, it's more expensive to produce there. Any bar less than 100, it is less expensive than the United States to produce there. So what about long-run production costs? Over enough time, the firm can change all their input amounts, including their plant size. Firms can get rid of factories they don't need or that are not helpful. They can reduce factory size. They can fire employees. All costs are variable in the long run. And this is something to put to memory. In any type of economics, all costs are variable in the long run. And that is something to put in mind here. And as for your long-run average total cost, we're going to consider costs in terms of average total costs. So let's take a look going forward. So here's your long-run average total cost curve with 5 different plant sizes. So depending on how large your plant is, your costs are going to be different. So as you can see, the more output we have, our cost curves are indeed different. Our cost curves are indeed different. So the long run average total cost curve is made up of segments of the short run cost curves of the various sized plants from which a firm might choose. The long run curve is also called the planning curve. Each point on the bumpy planning curve shows the lowest unit cost available for any output when the firm has had time to make all decisions in plant size. And here's your long run cost curve. The long run curve just envelops the short run ATCs. If the number of possible plant sizes is very large, it's going to approximate a smooth curve. Economies of scale followed by diseconomies of scale cause it to be U-shaped. What does this mean? Economies of scale is the notion that the more you make of something, it's going to make it more inexpensive to do so. And that's something we see all the time, especially with things like technological products. As they catch on and we make more of them, the cost comes down. But eventually, even still, you will hit a point where if you make beyond a certain point, that law of diminishing returns will kick in and it's going to actually raise your cost again. So your long run curve gets lower, the costs go down as output goes up, but then they start ticking back up again if we increase output to a certain degree. What are economies of scale? Well, economies of scale refer to the idea that for a time, larger plant sizes will lead to lower costs. And that's exactly what I went into before. An increase in inputs where there are economies of scale will lead to more than a proportionate increase in output. Labor specialization, or people specializing in what they do best, helps economies of scale because it makes up use of special skills. Proficiency is gained as workers concentrate on one task and time is saved. Specialized managers can achieve this because managers can better manage their workers with no increased costs, and managers can specialize in their expertise area. An efficient use of capital, those are your goods, remember, capital goods are goods that allow you to produce for the future. Efficient use of capital goods lead to economies of scale because high volume production warrants that the expensive large scale equipment that you buy, you're paying it off by making a lot with it. You buy all new robots for your factory. Hopefully they allow you to make a lot more so you could pay for that cost of buying them. And other factors leading to economies of scale, things like design, development, and advertising, they're spread out over larger quantities. So constant returns to scale occur when your average total cost is constant over a variety of plant sizes. When there are constant returns to scale, an increase in inputs will result in a proportionate increase in output. What are diseconomies of scale? If your company becomes too large, think of all giant companies that may have grown so large they actually started to suffer. If you grow too large, expansion may actually cause costs to go up. That's why we watch that curve go down and then tick back up. And with diseconomies of scale, as we increase inputs, we'll have less output, less than a proportionate increase in output. So if we increase inputs by 1, we might get less than a 1 increase in output. And what can cause this? Control and coordination problems are a big one. If your company gets so large you have a hard time controlling it, you may not have enough managers, or it may be too spread out. That's a problem. Communication problems. A large bureaucracy is going to make it very hard to communicate with all of your divisions and your employees and make sure everybody's on the same page. Really large corporations can alienate workers. You feel like you're just a faceless gear in a machine and you're working for a company that doesn't care about you. That's going to cause you not really to put in much effort. And finally, what is known as shirking. And what is shirking? Shirking is if workers get alienated or they feel like their company doesn't care about them, they may shirk or avoid work or do the very bare minimum not to get fired. So what is your minimal efficient scale or your minimum efficient scale? Well, your MES is the lowest level of output at which long-run average costs are minimized. And it can determine the structure of an industry. So where the MES occurs on an industry's long-run ATC determines if there will be many or few producers and how large will they be, really large, small, or various sizes. A natural monopoly is a rare situation where economies of scale extend beyond the market size, so one large firm can provide all the products more cheaply than a multi-firm market. That can happen, however, it's rare. Most monopolies actually raise costs when only one company is making something because it makes it them being the only game in town. And then they can charge whatever they want. But you can get a monopoly where if only one firm is producing a product, it actually brings the cost down. That's a rare situation. So here is a curve showing industries with an extended range of constant returns to scale. So these are often populated by firms of different sizes. Small and large scale producers will coexist and be equally successful. And MES occurs at output level Q number 1. So up to output level Q number 1, we have economies of scale. The more of something we make, the cheaper it becomes. Between Q1 and Q2, we have constant returns to scale. So as we increase, we'll get a proportionate increase in output. And after Q2, it's actually going to hurt us if we keep growing. So industries with economy of scale over a wide range of outputs will lead to a few large-scale firms. So think of oil companies, for instance. You don't have just one, but you don't have very many. Small firms cannot realize the minimum efficient scale and won't be able to compete. You can't make your own oil company and hope to compete with Exxon. You have to be a firm of similar size to ExxonMobil. If you just open an oil company and start drilling a little bit and trying to sell, there is no way you will be able to compete with the behemoths like Exxon or BP or anything like that. And your long run ATC curve is lowest only when there is a large output. So in this case, average total costs are going down to output for a long time. Your long run average total cost curve, that's what we're looking at here. So when you have a large output, that's what's going to do it. So let's take a look at things like gasoline prices. Rising gasoline prices will cause these short run costs to rise for firms that use this type of energy as an input. So if you own FedEx or you're one of their managers, you're going to see huge cost increases. Whereas a company that has nothing to do with physical transport, you're a software design company, you're not really going to be affected by a change in gasoline prices. Startup firms have been successful lowering their average total costs as they increased output and achieved economies of scale. And this spreads out R&D and advertising costs over a large number of units. So things like Starbucks, Microsoft, and Google, even though it might cost a lot to start up a company like that, if they become very successful, they can spread those costs out over all of their units they make or whatever they do. The Weber metal stamping machine is an example of a capital good. So it can make tens of thousands of components a year, but it's very expensive. It costs $180 million. However, it can make parts really quick and cheap. But no, not every company that does metal stamping should be buying a $180 million machine. It really only is warranted for companies that make a ton of things. So let's say you're a car company. This kind of machine would be something that would make sense for you. If you build millions of vehicles a year, it would make sense to buy a $180 million machine. In fact, car companies have many metal stamping machines, probably very similar to this. But if you're a company that makes metal signs and you make only a few thousand of them a year, you're not going to buy a $180 million machine to do so. So a machine like this would only be appropriate or warranted in really large factories. But in those cases, it would be beneficial from them because it would bring their costs down. Even though it's a very large fixed cost, if they make millions of units a year, their average cost is going to be pretty low. Things like newspapers have experienced massive decreases in revenues and subscriptions, raising their costs. Advertising revenue shifted to the internet, and newspapers, you might say, may be a thing of the past. If they raise their price, they're going to sell fewer papers, and that'll raise their costs even more. So legacy companies like newspaper companies are really in a bind because their costs have gone up while their revenues have gone down. Things like an airplane, a commercial aircraft requires large-scale production, which easily achieves economies of scale and requires few plants. But something like concrete, you need small-scale production for that. There are many producers. There are only a few airplane producers, and you have thousands of plants. So every industry is very different. That's going to bring us now to our last slide. Instead of things like physical equipment, computers are one of the new biggest cost drivers. And instead of investing heavily in their own computer systems like servers and networks, a lot of companies now outsource their computational needs to things like Amazon Web Services, Azure, which is owned by Microsoft, Oracle, and many other companies like this. And these cloud providers can take advantage of massive long-run economies of scale because they are absolutely enormous. They have massive amounts of computing power, and it's easier to buy some of their computing power than to build your own system or systems from the ground up. So previously, every company had to buy and operate their own computers, have their own IT department, service them, all of that, constantly upgrade them. Where now we can pay Amazon to host our website and handle all of our computing needs, and it's actually a lot cheaper for most firms. Now only really, really large firms buy and operate their own computational systems. If you're very large, it still might be beneficial to do it yourself, but for the most part, even quite a lot of large firms have now started outsourcing their computational needs to run better and bring down their cost. And that's going to take us to the end of Chapter 9.